In this video, we're going to cover some of the cleanup you may want to do on your logs before either ingesting them into your petrophysical project or before performing log splicing. So in this example, I'm actually going to cover two different versions of the same flow, but they serve the same purpose. So we've probably already by this point ran our log health check tool, and we've established that we have a number of logs across our well data set that have what we colloquially refer to as flat spots or repeated samples of the same value. And this is often deemed to be poor or misleading data. So a lot of times the desire would be to remove this data from your well set so it doesn't either affect the splicing process or your interpretation. To do this, we're going to use our log input tool and our null repeated log samples tool within a flow. So to do this, once again, we'll start with new flow, and then you can see here that I've got a log input block where I've chose my the database that I want to run it on here. And then I have several of these null repeated log sample tools. So this tool does operate on the alias table if you instruct it to, and that's how most people will choose to run this. And then it gives you the option whether or not you want to run this just on the top portion of the logs, the base, the top and the base, or the entire log. And then you can choose values for the minimum number of repeated samples and the value tolerance for a repeat. So the reason we have this block repeated several times is because it makes sense to run this tool across each of our log types. So here we're running across gamma ray, the SGRD curve, conductivity, deep resistivity, medium resistivity, and so on. And so what this will do, I have the same parameter set up on all these so I understand what it's doing, but it's basically going to trim off any values where we have the exact same value 5 or more times from the top and base of my logs. And we'll hit run here. And note that this tool is actually based in Python, as we can tell by the icon here. So you can actually go in and inspect the code for this tool if you want. That's of course optional. If you want to use it as an example for some of your own tools, you can do that. But it also means that sometimes it takes slightly longer for these tools to start up because we actually spin up a new server for you to run Python instances in. And we see here that it is ran, and it would have output a new log database called, in this case, clean1 example data. Now, remember that the first time I ran this, I ran it just on the top and base, and that's because that's where I normally expect to find repeated samples. So I said that we only needed 5 samples for this. If I wanted to go in and do this on the entire log, I may choose to set a higher threshold. And in this case, I've input the results from my first flow, and here in the second flow tool, I have the exact same repeated stack here, except now I have gone through and I've selected to perform this operation on the entire log, except now I'm requiring a minimum of 10 repeated samples. So I'm setting a higher threshold in this case. And I've done that for each of the logs, and I've ended this with a remove all null logs flow tool block. So in case any of the logs are completely nulled out, they'll now be removed entirely from the log database, and then I'll provide this with an additional output. Once again, to run the flow, I just click the play button here in the top center, and it will go through the typical process of initializing, running, and then finished. In this case, it's a relatively small database of only around 100 logs, so the flow should execute in somewhere in 15 to 20 seconds. If we want to inspect the output, once again, we can either look at the result database, or we can go in and look at the job log by clicking here on the sheet of paper. After running this flow, it may be useful to once again go in and perform another log health check analysis to once again look to see if there are repeated samples and what logs those are affecting. It's important to remember that some logs may have repeated samples, things such as your density correction curve, so your D row, or your caliper or bit size. You would actually expect there to be lots of repeated values within those logs. So remember, you probably don't want to use those as inputs here for the curve to evaluate in those tools.